Hello and welcome to the geotechnical engineering refresher. I am Engineer Raymond Solas. Okay, let's start with problem number 1. A clay has the following Atterberg's limits. So given, liquid limits is 63%, plastic limit is 23%, water content is 38%. Compute the consistency index. Okay, so for the solution, for computing consistency index, so the formula is Ci equals the liquid limit minus the moisture content W over liquid limit minus plasticity index. So we have those given previously mentioned, liquid limit, plastic limit, and water content. So we could compute for Pi or plasticity index. So we get Pi as 40, and getting the value of Pi, we could compute for Ci, which is 63 minus 38 over 63 minus 40 equals 1.09. Problem number 2. A soil sample has the following properties. Specific gravity is 2.67, void ratio is 0.54, water content is 11.2%. Compute the air void ratio. So for the solution, so we have the formula for air void ratio is equals to N times quantity 1 minus S. So N is porosity and S is the degree of saturation. So for the formula of degree saturation, so we have the moisture content multiplied by specific gravity divided by the void ratio. So computing that, given the values 11.2% moisture content and specific gravity divided by the void ratio, so we'll get 0.5538. Also computing the porosity, so we have void ratio over 1 plus void ratio, so we get 0.35. So substituting the values, so we'll get 0.156. Problem number 3, soil classification. The following soil has specified by the AASHTO system has the following results. Percent finer, the number 10 sieve 90. Percent finer, number 40 sieve 76. Percent finer than number 200 sieve 34. Liquid limit equals 37. Plasticity index equals 12. Calculate the partial group index for the soil that belongs to group A-2-6. So for the solution in this problem, so we need to recall the formula from the AASHTO. So it is for partial group index formula, we have GI equals 0.01, quantity percent finer at sieve 200 or F200 minus 15 close multiplied by plasticity index minus 10. So this is just simply a substitution of the values. So we get 0.01 quantity 34 minus 15 times quantity 12 minus 10. So we get 0.38. Problem 4. A compacted soil has water content of 16% and a dry unit weight of 0.9 um, unit weight at 0 air void. Determine the dry unit weight if it has a specific gravity of 2.7. For the solution, so we have the formula of gamma 0 air void, which is equals to the gamma of water divided by quantity of moisture content plus the reciprocal of the specific gravity. So we compute the value as 9.81 divided by 0.16 plus 1 over 2.7. So we get 18.5 kilonewton per cubic meter. So going back, so the problem is we get the dry unit weight, so which is 90% of the gamma 0 air void. So multiplying 0.9 to 18.5, so we get 16.65. Problem 5. A soil has a water content of 25% and a degree of saturation of 82%. Compute the specific gravity of the soil if it has a dry unit weight of 14.33 kilonewton per cubic meter. For the solution, so recall again the formula for dry unit weight, which is Gs gamma W divided by 1 plus E. So what we do is we transpose the formula. Okay, so we have multiplied the dry unit weight with 1 plus E and equate it to 9.81 Gs. Simplified for Gs in terms of E, so we have Gs equals 1.45 1 plus E. And then recall again the formula for saturation. S is equals to Gs W divided by E. And then we compute the value of E in terms of Gs. And then going back to the previous formula that we have the Gs equals 1.45 quantity multiplied by quantity 1 plus E. So we substitute 0.305 Gs and then we get the value Gs equals 1.45 plus 0.442 Gs, and then we get to transpose the values, so we get the value 0.558 Gs equals 1.45, so therefore Gs is equals to 2.6.